So I'm going to talk about the problem we had in class where we had a big circle. Well, it wasn't necessarily a big circle, but it was a circle. And we had in it was inscribed an n-gon. Yeah. And we were supposed to figure out if this would be theta. Theta, sorry, not theta. Whoopsies. No. Yeah. And we were supposed to figure out that as the limit of as n, which would be the number of sides, and the number of little triangles there, as n approaches infinity, find area. So, obviously we know that when n approaches infinity, that means there's infinite number of sides, which is exactly what a circle is. And that we know that this is a unit circle, which I think we're assumed it is. Then that would just make this the radius 1, and that would make the area pi units squared. So some of us already had that kind of tucked away, and oh wait, we can keep using this, but there's a couple things we could have done. We could have said, okay, why don't we try splitting this in half? I really can't decide what I want this at. Splitting this in half, and we'll make this a right triangle, and we'll just say that this is theta. So I remember there are two ways you could have done it, and this is one of them. And then you could have figured out that from that this would be sine theta, and that this would be cos theta. And then from that you could figure out this triangle, which would be sine theta squared so it would be not the theta squared, it would be sine squared. Sorry, why do I have a square here? Never mind. There's no squared at all. But of course you can't erase it, because that's just the type of people these guys are. Yes. Ah, there we are. Okay. So, no, it would be sine theta times there we are. Times cosine theta, and that would get you, see, an over 2 times 2 would get you one of these triangles. So you could cancel out the over 2 times 2, I'll just write it down. And that would be times n, right? Because you'd want to get all the little triangles inside, and that would be equal to, the amount of triangles would be equal to n, which is the amount of sides. So, all we don't have here, and sorry, this would all equal to area. And what we don't have here is actually what theta is. So we want to make theta in terms of n. And so, I found a really cool way of doing that. And how we would do that is we would just say, okay, how many degrees are there in the whole triangle, or in the whole n-gon? And we would find that there would be 180 because it'd be made up as little triangles, and triangles would have 180 degrees, so it'd be 180. It would be 180 times n. So we have, just want to put this up here. We have this triangle, right? It would be equal to 180. And then we would have that times n, because there would be n more of those triangles. So 180n. And that would be plus, okay, here, and then right in the middle of the triangle here, or in the end gun right there, that's all 360 degrees, right? Because that's just how a circle is, that would be how that is, it's any shape. And since that would be 360 degrees, you could subtract 360 degrees, and then you would just get, if the triangle is right here, we would just get these two. And so then you can divide that by 2 to get one of them. And then you have to also divide it by n, because there's still n of these. So that's actually theta, because that is one of those angles. And so now it's really cool. Sometimes this factor is annoying, and sometimes it's kind of nice. Right now it's both. You know what? 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 Forget it, just keep it there. And actually, sorry, this just really bothers me. There. Okay. So now if you have everything, you can have area, I'll just say that's A, equals, and this is kind of a funky formula, because like, it's like as it gets bigger, some parts of it get smaller, because it's like 1 over n, as shown there, and sometimes it's also times n. So, let's just quickly simplify this. Sorry, this is going to equal, see, it'd be 180 times n over 2n, minus 360 over 2n. So that's just going to make it equal 90 minus 180 over n. Right? And so we're going to have area equals sine of theta, which is this, times cosine of 90 minus 180 over n. And now it'd all be times, please. What? That'd all be times n. Try to make this look a little bit clearer. And the cool thing is, as n goes to infinity, this ends up equaling pi. We've plugged it into Mathematica, and Matthew actually did that, Matthew Salah, and he made it n equal like a big number. And it was really, it was just looked exactly like pi. So, yep. Cool stuff. Oopsies.